Okay, so for the slightly longer example 10 at the end of this section, we're gonna have to spend a little bit more time figuring it out. And actually, this is much more like what you'll see in an exam paper. You will not see the very straightforward example 7-8 where you just have to do one simple calculation. So the border of a garden pond consists of a straight edge AB of length 2.4, and that is this line right here on our diagram, and a curved part C as shown on the diagram. And we have a circle, centre O, radius 2. So here's our little radius. And it wants us to find the length C. That's our goal. We can't directly use the length is r theta, because although we know r is 2, we haven't got a clue what theta is at the moment. So what we need to do is pick out from this diagram somehow a way of identifying the angle theta inside the circle. And if you look closely, you'll see that what we have right here is a triangle that we know lots and lots about. So if I separate that triangle out from the rest of the diagram, we know that it is 2, 2, and 2.4. And this angle here is the theta, so this guy here is 360 minus theta. So if we can figure out this angle at the top of the triangle, then we're sorted. Theta is easy, the rest is easy. You could dive in now with the cosine rule, because we've got a triangle with 3 lengths, so the cosine rule with a bit of work will find you the other angle. But if you're a bit cleverer and you spot a shortcut, if we just drop a vertical line here so that it's at right angles, because this triangle is isosceles, we can just break it in half. It's got symmetry, and because of that we'll get a right angle down here. And that means that this little length here is now 1.2. That speeds up the process massively because I don't need to use the cosine rule now, which is a bit laborious. So now I'm looking at just this triangle here with a base there of 1.2 and a hypotenuse of 2, and I want to know this angle up here. Well, now we can just use SOHCAHTOA, basic right angled trigonometry, to sort this out. I have the opposite and the hypotenuse, so I want to use SOH. So I now know that sine of my angle x is equal to 1.2 divided by 2, or rather x is the inverse sine of 1.2 divided by 2. And then we're going to go to our calculator and we can do this really quickly. Sine of 1.2 divided by 2, close brackets, and at this point we need to pause and think about whether this answer makes sense, because this rule here, L equals r theta, this only works if we're in radians, and there is no way that that angle is 36 radians. 36 radians is way more than a full turn of a circle, because a full circle is just a little bit over 6 radians. So we must be in degrees on the calculator. And if we're in degrees, that's not going to help, because we would then need to use the more complicated degree formula to solve this problem. So, just like I showed you in the earlier videos, if we go to Shift Setup, change the angle unit to radians, I can just press equals again, and it gives me the much more helpful value of 0.644 radians. And now I know that L is r theta. Now hold on, that's not theta, is it? So theta is not 360, talking rubbish, 2 pi minus, and then not just one of these x's, but 2 of them. So 2 lots of 0.644. I can do this all in the calculator, and it's more helpful to do the calculator because the calculator will keep the accurate decimal value. So I want to do 2 pi minus 2 lots of the answer equals, and I've got 4.996 radians. This is the angle theta, so L equals 2 times 4.996 which is going to be equal to 9.992 meters. We might well round that off to approximately 10 meters, and that would be reasonable. 2, 3 significant figures is fine. That is pretty close to exactly 10 meters.